Hi, in this presentation, I will walk you through the highlights of this study. People tend to automatically segment experience at points of perceptual or conceptual change, also called event boundaries. Research on the cognitive and neural implications of event segmentation mechanism often assume that one group's segmentation pattern can reliably predict another group's or individual's segmentation. However, segmentation behavior can carry significant individual variability. In this project, we investigated how sensitive are measures of segmentation agreement to individual variation by examining the stability of segmentation agreement at a range of sample size. To do this, we analyzed segmentation performance from two separate datasets. In the first dataset, participants segmented clips from commercial movies in the lab. And in the second dataset, participants segmented videos of everyday activities on the web. We then used a bootstrapping technique to create distributions of segmentation performance at different sample sizes. We calculated segmentation agreement in 4 different ways, quantifying the group and individual level agreement. At the group level, we quantified a within-group agreement, or the extent to which individuals within a group identify similar boundary time points, and a between-group agreement, or the mean difference in consensus boundary placement between two independent groups. Next, at the individual level, we quantified the expected probability that an individual boundary placement overlaps with a group's consensus boundary placement, and the correlation between individual and group segmentation pattern over time. For all agreement measures, we computed 3 types of values. First, agreement values from segmentation in one video we call actual. Second, agreement values calculated using randomly generated segmentation data we call random. And lastly, agreement values calculated using segmentation data on different movies we call cross-movie. If measures of segmentation agreement are sensitive to information within the stimulus, it should be significantly different compared to random noise. And if it captures information that is video-specific, actual agreement values should also be different than cross-movie agreement. Overall, we expect actual segmentation agreement to improve with sample size, and its stabilization should be reflected in a nonlinear relationship. Stabilization should then start at the elbow of the nonlinear curve. First, looking at within-group agreement. Actual agreement values are plotted in yellow. Within-group agreement only stabilized for fine in-lab segmentation and coarse online segmentation. In contrast, between-group segmentation stabilized for all segmentation types, and stabilization began at sample size 10 for in-lab segmentation and about 6 to 8 for online segmentation, marked by the carets in the figure. Notably, both within and between-group agreement are significantly different than random agreement plotted as green diamonds and cross-movie agreement plotted as gray triangles. Next, turning to individual-level segmentation agreement. We see stabilization of both types of individual-to-group agreement in all segmentation grains of both in-lab and online datasets. Interestingly, stabilization started at higher sample size compared to between-group agreement, ranging from sample size of 10 to 16, again marked by the carets. All individual-level segmentation agreement is also significantly different than random and cross-movie values, and this differentiation is apparent at sample size as low as 2. Through this project, we have shown that segmentation agreement can be measured in different ways depending on the comparison of interest, whether it's in the group or individual level. We found that each of the different agreement measures are differently sensitive to variation in sample size, and that adequate number of sample is needed to capture stable segmentation agreement. Particularly, stable between-group agreement can only be captured with a sample size of at least 10 for in-lab segmentation and 8 for online. However, to capture stable agreement at the individual level, an even higher sample size is required. Lastly, this project also highlighted the value of using an explicit segmentation task. Despite the highly subjective nature of the task, we can observe segmentation performance that is sensitive and specific to the stimulus structure with segmentation from as little as 2 people. This is true for segmentation done in the lab and on the web. Thank you for your attention. For more details on this project, please visit my Q&A session.